Novo. Experience powering productivity. That's different thinking. That's Kennametal.
In order to start working with Novo, we will start with the job requirement. To work with that, you need to have your login ID. If not, let us create a new one. So let's sign up for an account, enter your email ID, your confirmation email, password, and your name, possibly, yes, and register. So what it does is it will give you an identity over here. Now let's start by working with a new job. So what it does is it will create you a new job sort of description where you can enter the job name, you can select what is the type of material that you're working or trying to machine, select the materials from the available lists. There are various amounts of various lists are available over here. So you can define the material and it will automatically choose its groups based on that. And this is the starting point where most of the other calculations or grade selections will help you when you select the material. That's why the material is very, very important. Now we'll go by searching the product family. Remember the job what you created is still active. So now let's start by facing the top face. This is just an example. Now I would like to use it with a 110 diameter cutter. Now, so there are a lot of options over here. So what we can do now is we can go for filtering process where I'm just looking diameter greater than or equal to 125 and my depth of cut I was looking for 3.5 mm. So this is whatever the filters that you want to do. Then you can go with a approach angle. So it filters down your cutters. So now you select what is the type of cutter you would like to have and then select the best diameter which you fit in, and now you can choose the insert for that cutter, and this insert is then will be selected based on what is the material or grade you can choose, and that's how you can review the recommendations for your suitable material. Then choose the adaptive item, how it has to be clamped in the system. So there again a lot of options. It's always better to go with a filtration mode so that it will reduce your search time. So you have come up with a good adapter, so it knows. So the adapter possibilities also are there. Now the important thing here is you can see the feet and speeds with which this tool can work. So you can, however, adjust what is the radial engagement. You are going for a full engagement. You can check with the power and the torque what is required on the machine, and then you can click OK. So you can also have the 3D view of the assembly, so how the tool would look like, and then you can add it to your job. So similarly, just before you do that, just give a proper name to it, and similarly this is how we can add the jobs as per our component. Now once this is done, you can create a report automatically, and then this report, if you open, it will have this information of who has created, what is the material, any notes you want to add, then each facing operation or the tool operation that you have selected, what is the tool, all the details of the tools are there with the power calculations. With these calculations, what we can do is we can inform the machine operator based on who is working on it, and then we can identify what are the power required at the tool, or else also know in the first hand what is the power available to run this cutter, so that once we have our machine capability, we can order them. So this is how it is very much important, all these calculations. To know more about feeds and speeds, I have created just a demo project, and let's look at the tool list. I have added an end mill over there, and I will select that particular tool, and if you see, observe over here, there are a lot of things that you can do, but right now we are concentrating on looking at this feed and speeds. It's a very interesting thing to do. It's very interesting and also encouraging, and we can have lots of fun over here. Let me expand this, and we can work here. So now what you are seeing here is there's an axial depth of cut, that is the AP as per the image, and then the radial width of cut, that's the radial engagement. So this is the engagement. And then we have the cutting speed and the feed. So all we need to play around. So let's say I will increase my radial or axial depth of cut to the fullest limit. Check what the feeds and calculations are there. So now that is the power required on the tool, and that's the torque requirement for that particular tool. And then you have this maximum chip thickness, that is, this is the maximum chip thickness which is available. So now let me reduce this engagement. So what will happen? See here, the power requirement changed. Now let's look at increasing the feed. I will go and increase the feed to the maximum, and now you see there is a change in the maximum chip thickness, and the power requirement is also not that much, okay, but still you can play around with this by using this feeds and speed. So it will give you a lot of in-depth information of how these tools can be used and worked upon. Okay, this was just a small demonstration. Next thing we'll do here is we'll search for the product, or we'll create the shoulder mill, and then we will make an assembly and then try to download the assembly. So what I've done is I've just went to a shoulder mill and I have filtered out, use the filters to narrow down the choices. I select the workpiece, and it's always good to have the knowledge about the workpiece, and then it will make our job very much easier in selecting the tools. Okay, so once we filter down the workpiece, and then let's fix up upon the diameters. What are the available diameters for that particular shoulder mill? And then let's fix up with the AP1. What's the maximum depth of cut? And there you go. So let's select the corner radius as well. So we have narrowed down too much. So this will be looking at this shell mill, and select the insert. So that's the cutter that we have selected, and then we'll select the insert. What is the insert? If you see, there are the status as new. So whatever the newly added objects will be displayed, so that you will know the recent items. When it selects the adaptive systems, it intelligently knows what are the best suitable adapters on the front end side, but on the back end side you need to select based on the machine. So once you selected that, and you can now have a look at the 3D model, how it looks once it is assembled, and then you can download the model. So you can heavy models you can open and download the current assembly. That will be downloaded as step files. Okay. So apart from 3D models, what we can also do is we can also copy take down a copy of the 2D drawing. So I'll pick a 3D model from the tool list and select the download, and then you will see you can choose what type of drawing that you would need. You can open an AutoCAD drawing, and it looks like most of the dimensions are over there, and it's a fairly legit drawing that we will get from the Novo. Also, you can do the PDF version of it. So CAD drawing, same operations, then just drag down and change the PDF file, and there you go. You can have the PDF version of this, the same drawing. That's how as simple as it is. So apart from downloading the files and other things, you can also place the quotation directly from the job.toollist that you have created. So in order to do that, you select the tool for which you need the quotation, and you need to have this account or connect account of the customer account that will enable you to start the business, or you can create a new business account with us. So once you are into that account, you can select there is also a minimum order quantity, so you can enter the quantities of the elements that you need, especially the inserts, of course. So, and then type in the purchase order number and shipping options. So when it has to be shipped. So that's the purchase order number that you have written, and then you need to check the availability. So this video was made in the year 2014, so that's how it is. That's why you see that 2014 over there. So once that is done, you place the quote, enter the email address to send the quote to, and then the quotation is placed on us. Okay. Go back to the return to job, and then you will see receive a PDF copy of the quote. So this is how you will receive the quotation. So apart from this, you can also place the quotation to your distributor, and also you can directly place the order based on the tooling package using Novo. So what else you can do with Novo? So here is a couple of minutes of video which will give you a newer idea on what you could do with Novo. Let's watch it.
Users can directly download a Kennametal tool assembly and use it within Vericut software with significantly fewer steps compared to manually configuring a tool for use in a simulation session. The process is simple. After building your tool list within Novo, click on the Job button and select the job you wish to transfer to Vericut. You can see that this job contains 3 tool assemblies. Click on one of the assemblies to view its components. The 3D viewer displays the complete assembly. This is showing the detailed model file. To export all the tool assemblies in the job, click Export Job. As a Machining Cloud partner, you can see that Vericut is one of the options in the dropdown. Select 3D Anti-Collision Model in step format. Clicking Export will save a zip file to a location of your choosing. You do not need to unzip this file. Now we are in a Vericut 7.4 session. Open the Tool Manager and select Import Tools, Novo Tool. Point to the zip file just saved from Novo, and all of the tools from the job are ready to be imported. That's it. You are now ready to simulate removing material using your Kennametal tool assemblies.
One more interesting feature what Novo provides is the modified standard tooling solutions. So have a look at this video and let us know your feedback.